one of the many components contained in ordinary air. If we could build a device that could effectively gather and condense moisture from air, we could harvest it using a huge surface area with pores of metal organic frameworks. This solar-powered device catches water vapor and passes it between two temperature zones to condense it. How the solution works. We harvest water from air with a device known as atmospheric water generator. This device collects water from human air and condenses it. Condensation is the process of extracting water from vapor. An atmospheric water generator later makes the water drinkable and useful. Science behind how it works. There are many types of models to be able to do this and many types of devices, but this is one of them. In a cooling condensation type atmospheric water generator, moist air enters the machine and pushes it into a condenser and then an evaporator coil, which cools the air surrounding it. This lowers the air to its dew point. The dew point is a temperature needed to be able to condense the water. After reaching the dew point, the water condenses. Then a controlled speed fan pushes the filtered water into a coil. The resulting water is then passed into a filter to make sure that any viruses and bacteria that may have been collected from the ambient is taken away, so that in result the water is clean. And then it is catched in a type of trash can that is something big and that can contain something a lot of water. My 2D model, harvesting water throughout air. Me and Lias created a 2D model that was able to represent a cube-like form presentation. This means that it is separated into two, the night and the day. And in this model, you can see how it works throughout the night and the day. So throughout the night that there is no sun, the moist air enters the box and is absorbed in the MFO. That is a sponge-like form. This MFO absorbs all the water particles and everything the moist air has. So when the day comes, the sun goes up and it produces heat. When heat hits the MFO, it produces water vapor. The water vapor is then condensed with fans. So this means that the water vapor is being cooled down to be able to make water. The water is then the water then is collected into a big hole in the ground or something big that can contain a lot of water and can then be transformed, or it can be transported to other places. What the water vapor and the condensation stage is different. So the water vapor is when the molecules of water are very separated and they're very far apart. But when water vapor condenses and is now turned into water, these molecules now join together and are sticked, and this makes the water be water. So how much water can it be produced? How much water can be produced after harvesting water from air? We harvest water by mixing ambient humidity, heat, and air to produce 5,000, 10,000, or 20,000 liters per unit per day with our air-to-water application. So this means that with this unit and with these devices per day, we can consume and we can make over 5,000 to 20,000 liters of water. But it all depends also in the moisture of the air. If the air isn't moisture, we will produce less water because it all depends in how much water is in the air. And with more moisture in the air, it means more water. Amount of water produced. Explain the factors determine the amount of water produced by the solution. Water vapor can help us identify the factors of how much water is being produced. Because the humidity capacity of air is regulated and temperature, the water vapor contents of the atmosphere fluctuates from place to place over time.
For example, a volume of air at 30 Celsius, that means 86 Fahrenheit, can contain up to 40% water vapor.
In producing water with this solution, the system would cost $2.80 and 55.62 Mexican pesos to deliver 1,000 liters of water per day. So, and this source of harvesting water from air and this device would, in fact, have some environmental concerns like a lot of carbon footprint, and it consumes a lot of energy. Visual display and efficientness. So as you can see in the purple table below, it shows the amount of water that has been dropped, so rain, the amount of rainy days in 2022 in Monterey. In this table, you can see that in 2022, it has rained an average of 6 days a month. That is a very low amount. And in the green table, you can see that in Monterey in 2022, the humidity level has been an average of 60% all year. You can only extract water from air if the humidity level is above 20%. Because the humidity level in Monterey is 60%, it means it is possible to extract water from the air. And it means that it will be very, very useful. And it means that in Monterey, because of the humidity in the air, it means that a lot of water can be produced by it and a lot of water can be harvested and condensed into water from the air. Pros and cons of harvesting water from air. Pros: direct drinking water. There can be small and big, can produce water from air. It is portable and more economical than other water supplies. And the cons, the bad things: it requires a lot of energy, it has a high carbon footprint, it's inefficient, and not affordable at all. The work started. So the work started, as you can see in the first link, it is small because I only grabbed a little bit of information, and the second link, it means that it is a big website. So I was able to catch a lot of information from that website. Thank you.